In Lecture 3b, we have completed the design process 1 and 2. Okay students, let's we all now proceed to the next step. That is, section classification. Okay, we now proceed with the example. Once the design bending moment and the shear force have been determined. Next, we need to classify the section. The section is classified based on the strength and section classifications. For your information, the bending strength of the section depends on how the section performs in bending. If the section is stocky, that's mean, has thick flanges and web, it can sustain the formation of a plastic hinge. On the other hand, a slender section, that is with thin flanges and web, will fail by local buckling before the yield stress can be reached. To classify both of the strength and section of the given UB, first we need to have the details properties of the UB 3b-Classification section, as shown here. First, let us determine the strength classification of the given beam. Table 3.1 is used to determine the nominal values of the yield strength and the ultimate tensile strength for the hot-rolled structural steel. In our example, the steel grade that we used is S275, while the thickness of the flange is 11.5 mm, and the thickness of web is 7.4 mm, as both thickness are lesser than 40 mm. Therefore, from Table 3.1, we can see that our strength value, that is Fi equals 275, and Fu equals 430. To summarize, here, for UB 3b-Classification section, the thickness of flange is 11.5 mm, while the thickness of web is 7.4 mm. According to Table 3.1, as previously shows, we can conclude that the tensile and ultimate strength of the flange and web elements is 275 and 430 respectively. Okay class, next, we need to classify the cross-sections of the given beam. To do this, you must refer to Clause 5.5, EC3 Part 1 and 1. In general, the cross-section can be classified into 4 classifications, which have been listed in Clause 5.5.2. Do you know what is means by Class 1, 2, 3 and 4? If the designed section falls under Class 1, it means that the section is considered as plastic section. Plastic section allows the whole cross-section to fully develop plastic hinges, and the rotation is allowed based on the plastic analysis required. The structure will only fail when enough number of plastic hinges developed. Hence in this case, no local buckling will occur. Class 2 is compact. On the other hand, compact section is still allow the full plastic moment to develop. However, the section has a tendency to experience local buckling due to failure to redistribute moment. This means the section only have limited rotational capacity. In contrast to Class 1 and Class 2, under applied loading condition, the Class 3 section is still able to achieve the yield strength. However, the local buckling is liable, which halt the development of the plastic hinges. Thus, Class 3 is classified as semi-compact. Finally, the Class 4 section will fail due to local buckling at most of the cross-section throughout the beam. The section is unable to achieve yield stress, and this Class 4 section is called slender. To classify the flange section, first, you need to evaluate the strain parameter by calculating as shown here. The value of Fy is calculated in the previous step. Next, what you need to do is to calculate the flange slenderness ratio. The outstand flange length, C, can be calculated using the shown formula. Table 5.2 shows the limit of each class section. Bear in mind, the dimension of C for the hot-rolled section is defined as highlighted in the red box. Meanwhile, the green box highlight the dimension of C value for the welded sections. From previously calculated, the slenderness flange ratio is determined to be 6.25, which is lesser than 9 times of the strain value. Therefore, it was concluded that the flange is fall under category Class 1 section. To classify the web section, like the flange classification, all you need to find is the strain parameter by calculating as shown here. The value of Fy is calculated in the previous step. Next, what you need to do is to calculate the web slenderness ratio. The C value is defined as shown in Table 5.2, Sheet 1, of 3. Table 5.2, Sheet 1, of 3, defines the length of C value for the web. From previously calculated, the web slenderness ratio is determined to be 42.8. Refer to the column 2, parts subject to bending. The value 42.8 is lesser than 72 times of the strain value. Therefore, it was concluded that the web is fall under category class 1 section. After we have determined the strength classification and the section classification, we can now conclude that the UB 356, 171, 51 section falls under the class 1 section. Usually, during the real design situation, it is common that the web and flange slenderness ratio are referred to the table of dimension properties. Alright. Now, let's do some exercises. We will discuss the solution on our online class session. Okay class. Here are more questions. Good luck. The next lecture will be on the resistance of cross-section to bending and shear ULS, and the resistance to shear buckling ULS. See you on the next lecture.